Welcome to the #1 show and the source of truth for all things MedTech. Here, we reveal the secrets and stories behind the investments, science, and commercialization of the MedTech industry. Every week, we'll take you on a wild ride with the biggest names in the game, from entrepreneurs and investors who are shaking up the market to healthcare providers who are revolutionizing the way we think and practice medicine. So hold on tight and get ready for a journey like no other. This is the State of MedTech. What's going on, everybody, and welcome to this episode specifically on artificial intelligence. We talk a lot about AI today, but how do we essentially design and, more importantly, develop the right type of AI-enabled MedTech products? And of course, the one person who, in my opinion, has a deep understanding of this is Dr. Daniel Burnett, who's not only a physician and entrepreneur, but also the founder of Theranova, which is an amazing MedTech incubator with a variety of portfolio companies focused on automating specific processes, gaining data, and then developing ML, machine learning algorithms to hopefully get to AI, right, in terms of solving a problem. So Dr. Burnett is a notable figure in the MedTech space and really somebody who embodies the entrepreneurial spirit. So let me tell you a little bit about his background. He, graduated from the University of Pennsylvania School of Bioengineering and decided that he wanted to contribute his skills to the FDA. And so he spent time at the FDA testing medical devices and then writing congressional reports on the state of the art of technology. And not somebody who's going to essentially rest on his laurels, he decided at that point that he should go and pursue a medical degree and an MBA degree. So he did it both combined MD, MBA degrees at the prestigious Duke University. This accomplishment was quickly followed on by a one-year internship at the renowned Mayo Clinic. And that's where he started getting a lot of insight and inspiration about medical devices. Today, he's a licensed physician in California, which really reflects his deep commitment to advancing medical science. Dan ended up honing his business acumen as a general partner with MedVenture Associates, which is a medical device venture capital firm based in the Bay Area, and equipped with this unique blend of both medical expertise and business, right? He then launched Theranova in 2006, which is a phenomenal incubator. I spent time there when I was head of marketing or head of growth at Potrero, and it's nothing short of magical. So Theranova is a San Francisco-based medical device incubator and, has since given rise to 12 portfolio companies and raised over $280 million in venture capital and $13 million in grant funding. Theranova by itself has issued about 51 patents under its belt and successfully introduced 2 products to the market, one of which is a sensor-enabled urinary catheter, which is the accurate monitoring system at Potrero, and Potrero specifically evolved to become a predictive health company, right? And more specifically, they received FDA breakthrough designations for their device algorithms. In addition to his role at Theranova, he's assisted in raising over $250 million for those 12 to 14 other Theranova spinouts. It's hard to keep track of how many companies are coming out of there. And again, he's the inventor of a variety of patents, about 57 issued, 180 pending worldwide, and that number is growing. And in a recent development, he joined the University of California, San Francisco as entrepreneur in residence with QB3 and has adjunct faculty designation at the Department of Bioengineering. And in this episode, we dive in to talk about what actually defines true artificial intelligence. How do you develop a medical device where you're automating a specific physiological function or sign and develop that into the data needed to develop machine learning, and then to Dan's definition, what's called artificial narrow intelligence. So we'll cover all that and more. It's a great episode, especially in my opinion, if you're an investor. This is the episode that you want to listen to understand this. Now, if you're a clinician listening to this, we are also giving a CME credit for this. So you can unlock your CME credit. Just click the link below, write a few sentences of what you learned, and then you get a free AMA PRA Category 1 CME credit. And lastly, if you're a CEO, if you're a founder, and you're trying to attract investors at scale, you're trying to get commercial traction, reach out to me because I love working out with startups. So if you're interested in gaining a little bit of a free consultation with me, go ahead and go to khateebandco.com and schedule time with me. There's a link on my website, or just shoot me a message either through my email or hit me up on LinkedIn. So with that being said, let's get on to the episode with Dr. Dan Burnett of Theranova. Welcome back to another episode of the State of MedTech. I'm your host, Omar Khateeb, and I'm joined by an old friend, a good friend, somebody who I have a profound amount of respect for, and that's Dr. Dan Burnett. Dan, thanks so much for joining the show. How are you doing?
Great. Thanks for having me, Omar.
Yeah, absolutely, man. I mean, it was kind of funny because, the show's a little over a year now, and then I was like, man, Dan has not been on the show. So, I mean, you're somebody who's extremely busy. You're a former physician turned entrepreneur. You have this amazing incubator with Theranova. That's for a lot of the audience who don't know. I mean, I got my start, I guess, really in Silicon Valley at a company called Potrero, which spun out of Theranova. And so I guess we'll kind of cut to the chase. AI was a big buzzword like many years ago, where the joke was like, when you're raising money, you call it AI, but when you're actually recruiting people, you just call it ML. And,
yep.
Now with like LLMs and, for the audience, it's large language models and generative AI, it's kind of back, right? And I think there's a lot of medtech companies who talk about AI, to raise AI, they pretend they're doing it and they're not doing AI. So, I felt like you were the perfect person to have on to talk about the risks and opportunities for investors in this area. So I'll kind of sort of let you take it from there.
Great. Yeah, thanks. And you're definitely right. The AI ML line is a little bit blurry, and the buzz of AI is huge, but largely most of it is still ML. Even these large language models could best be classified as ANI, artificial narrow intelligence. We're nowhere near, I think, artificial general intelligence, where you can throw a problem at a program and have that program figure it out if it's completely naive to that problem. And that's what most people think of when they think of artificial intelligence. Artificial narrow intelligence is when you have software and an algorithm that can solve specific problems that it's been trained to solve and to learn in a way that it's been programmed to learn. And that's what most AI in MedTech in particular, all AI in MedTech is. Of the 521 cleared devices that are ML/AI enabled, every single one of those is ML, and every single one of those in practice is a fixed algorithm developed using ML. So unlike the rest of the world, for example, chatbot GPT, I'm sure people have heard of that now. That's an evolving algorithm where it's getting better and better, and it pulls from more and more data sources, and it continues to grow, and that's been programmed to allow it to grow and improve based on data coming back in. That is not the case in MedTech right now.
I got to go back and ask you. You call it chatbot GPT. Can you expand on that? Why are you calling it chatbot GPT? I know why you're calling it that, but I want you to explain to the audience why.
Yeah, well, it started off as a chatbot is why, and so it's just one of the ways that it can be referred to. Now it's Chat GPT, I think, and especially I think they're on GPT-4 now. Is that where they are?
They're on GPT-4. Yeah.
Well, and it's. Oh, sorry.
Oh, no, yeah, go for it.
And it completely changed the landscape, right? In January of this year, AI and ML was still something relegated to movies and the future and Ray Kurzweil's 2047 prediction for the singularity. And then ChatGPT splashed on the screen, and all of a sudden it's doing things that people never would have dreamed of. It's scaring the hell out of radiologists since it passed the radiology board last month. I think it was last month. And it's also passed the exam, or had good scores and passed the law and business school exams. So it's a pretty incredible piece of artificial narrow intelligence.
Also, very good bedside manner,
Yeah.
Which is interesting,
Unlike Google's first chatbot, if you remember that guy, I
forgot what it was so bad. Called, yeah, didn't they have to take it offline because after a few weeks it turned into a racist 18-year-old pedophilic Nazi or something.
Yeah,
it didn't bode too well.
And that was not.
Is it Google or Microsoft?
Exactly.
No, maybe it's Google. Yeah,
one of them. Google, I think.
Yeah,
it's not what they wanted. It's just people messing with it, but it didn't know. and people were messing with it because it was programmed to learn in a specific way, and people figured out how it was learning, and they turned it into that monster.
Yeah. So, for investors, especially those who don't have like a technical background, and especially like what I would say is, I think more seasoned investors, like they're not going to have this issue because they have plenty of associates and people doing due diligence. But especially if you're an angel investor, or let's say a family office, and you're like going into MedTech, which a lot of these family offices and LPs have a lot of money, they may not have the ability to sort of think through and assess, is this really AI or not? Do you have like 2 or 3 ways that, like heuristics even, that you're like, if this, then that, and that would be it, it's not AI?
So I don't use the term AI typically. I use machine learning because AI I feel like is an overreach. But even then, for machine learning could be as simple as a multivariable correlation. And that's what some of the earliest 510K on an AI ML enabled medical device, I think it was from 1994. So, and they consider that because it was, I think, a recursive multivariate correlation. And that's essentially, a lot of these things are versions of that, right? Like the convolutional neural network is now a much more advanced form of that. But these are all simply machine learning algorithms that are usually based on, especially for MedTech, some sort of ground truth. So it's a supervised machine learning algorithm.
And, for the audience, if we can quickly define sort of like machine learning and AI, but like one way I like to think about it is that in order to get AI, you kind of start with machine learning and feeding it some data sets. But, I'll kind of let you take it from there. But how do you draw the delineation between like an ML and AI?
Well, typically ML is more what the FDA is comfortable with, and it develops a fixed algorithm, and it's usually not something that is a living, growing, learning algorithm beyond that. AI is more an evolving model that continues to get ground truth and continues to learn in a way and evolves in a way that allows its algorithm to become more and more powerful. So that's why ChatGPT is an example of that. It's continuing to pull from larger and larger data sets. It's getting feedback from its users, which it uses as ground truth to figure out what its users want, and it's getting better and better at what it does.
Got it. Yeah. One example that I kind of like, and at least this is how, after working at Potrero, which, spun out of Theranova, I really like that model when it comes to, ML AI, which is, for Potrero, it was hardware, as a critical care monitoring unit that automated a function. And in this case, it was, we have intra-abdominal pressure and urine output. I'm going to focus on the urine output, first, just because it was the acute kidney injury is really big, but essentially automating the function of measuring urine, right? So instead of having a nurse doing everything, you had this monitoring system that automated it, right? Yep. And through that automation, you also accurately and precisely started capturing data, which was not ever accessible. And for me, I feel like the best clinical model and business model for MedTech product, which is hardware that automates something for the first time, captures continuous data, and then that data, you're able to build ML models off of that. And then at some point, like depending on what it is, maybe it can become AI. That's how I feel like the right approach is. Am I wrong in thinking of it like that?
No, you were very helpful in evolving that platform at Potrero. So that's exactly how I think we were thinking of it, and we still think of it, which is the greatest opportunities in my mind in MedTech moving forward will be those that focus on proprietary, clinically actionable data streams. And there's a few that is a little bit.
Can you break that down a bit, like in terms of like how do you assess something that's proprietary and then more importantly like actionable? Because I think this is the other thing, Dan. And if you get like out of MedTech, this is the problem I think with a lot of these data companies and quote unquote AI companies, is that they have like really cool stuff. You look at it and you're like, oh, this is really great. But like, what are you going to do with it? And especially like in medicine, I think doctors are just kind of overwhelmed with all this data. And a lot of times it's just like, okay, like what actions are going to lead to it? Or are you going to get out of this? Like, is this actually going to make a difference? So how do you break that apart in terms of like for an investor looking at something like A, is this proprietary beyond just like an IP search? And then B, is it actionable?
Yeah, great. And I can unpack that a little bit. first part is proprietary. If your signal can be obtained via a Fitbit or any sort of, oh, you got that cute little one in the background.
Yeah, sorry about that.
No problem. That's life nowadays. If you have something that can be acquired by a Fitbit or an Apple Watch or a Samsung Watch, and it's just a regular photopleth and or motion sensor accelerometer, then you're going to be competing with the Apples, Samsungs, and Googles of this world, and they have much more data and much more, of course, resources than just about anybody, right? And Amazon as well. So one of the first key in my mind to be successful is you need to find the data stream needs to be proprietary. So have some sort of a patent wall around the acquisition of that data, of those data, and then which it will enable you to have a competitive advantage moving forward and not ultimately falling to the much larger, incredibly resourced competition out there. So proprietary is one of the two critical factors. And then the second one is obviously clinically actionable. So you need to have data that will allow the clinician to act in a way that's either going to improve outcomes or reduce costs or expand access to care for health equity reasons.
Got it. That makes a lot of sense. And on the proprietary side, like one thing that, and I'm sure like knowing you, like that you purposely designed it to be this way, but when I look at Potrero, for example, I think there's this new model now or category, at least in the investments of thinking about like who owns an organ, right? And so like in Potrero's case, like they are getting continuous data on like thousands of Accurant devices that are capturing urine output data and digitizing the kidney. And I feel like the new frontier in medicine is like whoever owns the most proprietary and actionable data owns that organ, like outright. Yep. Would you agree with that?
I do, definitely. And even if Potrero doesn't have the best algorithms, which it does have a very powerful algorithm, it's got their AKI predict right now, which is outperforming NephroCheck. It's got a sensitivity roughly equivalent to NephroCheck, a specificity that's much better at 0.76, a positive predictive value that's much better than NephroCheck, and the time in advance for an alert is over 3 times earlier. So it's 41 hours instead of 12 hours, all by tracking and trending these data. And the way Potrero did this is by saying, to your point, Omar, we're going to own the kidney. And there's the 3 data streams that are extracted at Potrero are all relevant to the kidney. Well, obviously, we get urine output in a way that's much more exquisite than existing devices since it's not susceptible to airlock. So every drop monitored by the Potrero device is a drop that came out from the kidney. The bladder is no longer a reservoir. And so having very accurate real-time kidney output and not just bladder output, it enabled some of the facets of this machine learning algorithm. Temperature is critical. One of the biggest causes of acute kidney injury is sepsis, and in sepsis, temperature is a big factor. A fever is, unless somebody's immunocompromised, the fever is almost always pretty universal there. And then the last one is intra-abdominal pressure, which is both a symptom and a cause of acute kidney injury. So with Potrero Medical's device, we had 3 factors that we could either be a predictor or a cause, or one of the sources of causation of acute kidney injury, which is why we felt very strongly that a machine learning algorithm using these 3 parameters would be able to better predict acute kidney injury, which we were able to do.
That makes sense. I think kind of the new way forward for maybe not a lot of medtech companies, but especially on the venture front, is just like, I think in the past, the idea was like, who can own a procedure? And I think that made sense before because technology wasn't moving as fast. It was a little bit easier to kind of get into a hospital and then like take up space in the OR and just sort of own something. It's just not the case anymore. Everything's becoming more digitized and more data driven. I think sort of the way forward for a lot of venture investing, I think, is to ask like, who cares about owning the procedure? I think the idea is like who can own the proprietary data and proprietary information around like specific organs. Like that being said, like, Theranova has like a lot of other like really interesting companies. Do you mind talking about some of those that sort of have the same clinical and business model as Potrero in terms of like trying to own an organ?
Great. Yeah, we've got several, and the two that are the most relevant are a company called Gravitas Medical and Cardiospire. Gravitas Medical is a company focused on developing next generation enteral feeding system, and one of the big components of that is the enteral feeding tube. And as with Potrero, what we did there is we took what's an otherwise commodity, stupid device in the body, but had to be in the body for a purpose. For Potrero, it was draining the urine. For Gravitas, it's delivering enteral feed. And then we added sensors to that device that we felt would enable machine learning algorithms, because the data would be clinically actionable and therefore could be used by the clinician to guide care, but would be even better used by a supervised machine learning algorithm to guide care. So, and Gravitas uses impedance and temperature to both detect placement of the feeding tube to ensure that it's not in the airway, that it's in the stomach, and then to monitor the feeding and monitor for dislodgement of the tube, which are two things that are critical especially in the young patient population, the neonates and pediatric population.
So with a company like Gravitas, is it necessarily an organ that you guys are trying to own, or is it more process? Like when you have all that data, like what's the digital moat that Gravitas would be essentially creating?
So it is owning essentially the enteral feeding market or enteral feeding process, and that could be seen as owning, in my mind, the stomach and intestine, right? Owning the GI tract, at least with respect to its absorption of nutrients. So that's how I look at that.
So if you have that data on absorption of nutrients, I mean, what are the actionable clinical steps that you can get out of that? So if you have this data that's telling you like rates of absorption based on like age and pathologies and everything, how do you see that play into like sort of the bigger picture in terms of the care of the patient?
Yeah, so good question. I'll use the example in the pediatric population. So you've got a baby in the NICU, and it's an art not only to place the tube, but then to dial up feedings. And they dial the feeding up, and then the nurse uses their art to figure out, is the belly rumbling? Is the baby digesting? Is it full? Is it backing up? Sometimes they'll get gastric residual volumes, but those are tough to do because you have to aspirate from the tube, which gets up against the mucosa. And it is a real art right now. And because of that, there's variability in practice, and there's inefficiencies. So those inefficiencies mean that a lot of these neonates end up on both parenteral and enteral feeding, meaning they get fed through their veins and through their nasogastric tube, with the goal of getting them just to the nasogastric tube. But they end up on both of those for a week to 2 weeks. Now, the time to get them to be fully fed by the GI tract is called time to full feeds. And that time to full feeds is critical because not only is the baby more likely to have failure to thrive the longer it is without nutrients, but it's also the longer that the baby ends up having this percutaneously inserted central catheter, a PICC line, which can cause infections that the hospital is dinged for. So in this case, knowing when the baby's stomach is empty definitively, and knowing that the baby's ready for more food before that 3-hour check that the nurse has allows, or should allow, I should say, we haven't proven this yet, but it's just like Potrero, where we had a feeling that these 3 parameters would help discern AKI. This should allow us to get to full feeds faster, which is less time with the PICC line and less time in the NICU.
Got it. That makes a lot of sense. Right now, like as a clinician and entrepreneur, are there any specific areas that kind of excite you? I mean, you got your hands full already with your portfolio companies, but like any specific areas of medicine that sort of excite you, knowing like where the technology is today with AI and ML?
Yeah, I would say excite and scare me. Any sort of technology that is based on a digital image is just ripe for absolute domination by AI. And there are 3 areas where AI is, there's probably more, but 3 that I can think of where AI is ripe for domination. And there's essentially no need to be having healthcare practitioners do this at all. Or if they do it, then it's just purely supervising the AI on cases that are outlandish that the AI hasn't seen yet, although that's going to be very rare because many of these are trained on hundreds of thousands of images and millions of images. So that's radiology. The ChexNet out of Stanford is better than a radiologist at detecting 4 of the critical pulmonary conditions, including pneumonia. So radiology, I forgot who said it, but he literally said that there's no point in training any radiologist moving forward because it is a field that is already digitized. It's incredibly easy to feed massive volumes of data into any sort of an AI, and it's supervised because we have radiology reads of these same images. So you can do incredibly large data sets here, where in medicine it's much harder. As you know, at Potrero, even to do this acute kidney injury algorithm, we had to get IRB approval and patient consent to get the data as to whether or not they had acute kidney injury and when it was diagnosed, in order to feed that information back into the algorithm. So the beauty of what the radiology field is what they're doing there is they can de-identify these images and get them in huge quantities with the physician readings of the images and use that to supervise their AI. There's also, and the other 2 that are digital images are evaluation of the retina and eye imaging, ophthalmology. And then the other one that is going to be histology. Histology is...
Why histology and not just are you considering pathology as part of histology? Okay, yeah.
Histopath. So, and this has been going on for a while. I think when I was back in venture back in 2005, they were already automating 80% of pap smears that came through. They would take a picture, the computer would analyze it. If it was completely clean, it just said clean. If it got confused at all, it would bump it to a pathologist who would then rate it. And I'm not sure if back then, if they were feeding it back into ground truth to make the algorithm and the software better, but that is what they do now. And it's just getting better and better. And essentially, pretty soon, it'll be better than most pathologists, if it's not already.
Yeah, see, and I think those are cases where AI makes a lot of sense because, I mean, if you look at radiology, even before the advent of but I don't say the advent of the internet, but essentially that's something where everything was looked at using digital images, right? There's a library of millions of those things. And, for something to get close to AI, you have to feed it an infinite amount of data. That makes a lot of sense. And there's going to be no radiology, even in the rare cases, because a radiologist who's really good at picking up on a specifically rare case means that they have technically themselves trained themselves on finding that image. And that's pretty much the same thing. So in that case, yeah, I mean, as controversial it is, it's almost like there's no point in training radiologists moving forward. I think though, I'll make kind of a really, crazy prediction. I don't think AI is going to make anybody unemployed in the next few decades. I think similar to when computers came out for librarians freaked out. They're like, there's no reason to have a librarian anymore. But if anything, it created more jobs because you need somebody to manage these systems. I think that it's going to change things that you're responsible for. But I don't know if in the next let's say 2 or 3 decades, there's going to be a bunch of radiologists that are just unemployed. I don't know. I mean, I could be wrong about that, but I feel like somebody's going to have to manage these systems, and it's just going to change the way we do medicine. But I don't know if you agree with that or not.
Well, it's definitely going to change how they do things, and it may mean that they are more computer scientists than radiologists now.
That's a good point. Yeah, I think I agree with that. Yeah.
So, go ahead.
I know. I was going to say the other side of it where I think AI is going to be really interesting is on the application, in surgery for computer vision, right? So I think one of the things about, if you think about when you're going to surgery, either you're getting something fixed or getting something removed, right? In the case of being removed, it's cancerous, in which case you need a surgeon to know where the clear demarcations are of a tumor, right? And not leave anything behind. And I think that's where computer vision and AI is going to have a huge impact. Do you feel the same way?
Yeah, I definitely do. And I think it's going to start off as an adjunct and eventually it'll be more and more automated. When I was at Duke,
the actual surgery?
The actual surgery, yeah. Now this is, if we're talking about the next decade, then no. If we're talking about the next 2 decades, maybe no. But if we're talking about the next 3 decades, then I would say some procedures will be largely automated. Even some of the orthopedic procedures, for example, one of the robots, it essentially doesn't do the procedure for the physician, but it sets guidelines on where they can shell out the bone, and then the physician just runs the router around, and it essentially shells.
Yeah, exactly. Like that with the I think Mako. Yeah, no, you're right.
Yeah,
it's like that. Technically, that that can be easily automated, right?
Right. And when I was training at Duke, we had a very militaristic surgeon program there.
It sounds like a surgery program.
Yeah. Oh, it's a very rough surgery program. It's very militaristic. And the Dave Sabiston was the cardiac surgery. He was the guy that was one of the pioneers of CABG, coronary artery bypass graft. And his fellowship was a 10-year fellowship. They called it Decade with Dave. And the divorce rate was over 100%. Because people would come in married, get divorced, get remarried, and get divorced. There was enough of those that the people that didn't get divorced were weighed out. So, but there was an expression there, or a joke. It would be a joke if it wasn't true, but this is how they felt, which is, what's the problem with every other night call? Being on call every other night. You miss half the cases. Most people would say you have no life, right? You sleep at the hospital and then you go home and you recover for one day and then you sleep at the hospital again the next night. But it's the mentality there was you miss half the cases. If you have a robot that is learning on that's learning based on physicians using it now, it's not missing any of the cases. It's getting them all. Eventually, these robots will have millions of surgeries, including the outliers with incredibly abnormal anatomy, and they'll know how these surgeries can go wrong and what happened and how the repairs were done. And eventually, I think I would rather have a robot that's seen millions of surgeries operate on me than a neophyte, right? If you were going to have your a coronary artery bypass, you don't want some fellow fresh out of training doing it. You want the surgeon that's done 500 or 600, 700 at least.
Yeah, and I was going to say, I was like, if you think about how people pick their healthcare today, we technically do that already. Because like if you one of my family members required a quadruple bypass. We didn't do that in my home. Yeah. Oh yeah, this was many years ago. They're doing great. But we didn't do that in it was my father. We didn't do that in my hometown. I mean, we were in El Paso, Texas. There's like a medical center and everything. We went to Houston, right?
Yep.
And got it done by like one of the best there,
Yep.
So I think like people are already doing that. Like when something really big, it's like, oh, who's the best I can go to? And I think, I don't know, this concept of democratizing medicine is like kind of thrown around as this like stupid catchphrase by like too many MedTech companies, and it's kind of getting annoyed. But like, I think the real democratization of medicine is the advent of AI and machine learning to actually standardize these procedures. So like, you shouldn't have to like pick, or if you have more money, you get to go see the best surgeon. There shouldn't be such a thing, And
the same is true with anything, right? As you know, the medical care is incredibly variable, right? There's the expression, what do you call the person that graduates last in their class at the worst medical school in the country? Doctor.
Doctor, right? Yeah.
And so, and that not the graduation in your class determines how good of a doctor you are necessarily, but the reality is there's, I would say roughly the 80-20 rule, right? 80% of doctors are very competent, and there's the 20% that are you wouldn't want to send your family members to.
There's some surgeons, academic surgeons, who are like double board there's one in particular I'm thinking about, double board certified. I wouldn't let that guy open a can of tomatoes, let alone like operate on somebody I love.
Yeah. Can you drop some names for us?
Definitely not.
Just kidding.
I think this is why they call it FU money, is like you just get to a point where you can just say anything you want. I'm almost there. I like to act like I got that kind of money, but there are some limits where I'm like, nah, I don't want it. I mean, technically, there's nothing bad would have happened, but he is a nice guy. I'll be honest.
Yeah.
And I will say,
I was totally joking.
No, you were. You totally want me to drop the name, but that's okay, Dan. That's okay, man. Why not? If I were you, I'd be pressing for the name. It's somebody I'll tell you that though.
Oh, geez.
It's nobody not somebody you know.
Okay, good.
Yeah, somebody you know.
Okay, good. What I was getting at is, if you have just for routine medical care, that should be 100% an algorithm. And this is what I saw happening in medicine and why I was so comfortable never practicing. When I was at the Mayo Clinic, they had these things called care maps, and I hated them. Somebody comes in with shortness of breath and swelling at their ankles. Okay, get out the CHF care map, and all you do is check the boxes and pretty much check all the boxes because it's been designed to be optimal care in the ER for somebody with CHF. And this wasn't me being on like an episode of House where I'm problem solving. This was me just checking a bunch of boxes based
glorified
on
box checker.
Exactly, based on presenting symptoms. And that's
was
when
that
I realized,
the day you're like, I don't want to be a clinician. I need to go be an entrepreneur. Was that the day?
No, the day was, I think, about a year later when they came out with a study on how these care maps improve care. And that's when I was like, oh, crap. This is where it's going. It went much more slowly than I thought. I mean, I would have thought for sure there'd be some sort of algorithm already where somebody presents with these certain symptoms. You order a specific set of tests to further cone down the differential diagnosis. And when based on those results, it goes into an algorithm that asks you to order more tests, different tests. And eventually you get to the right answer every time with that first visit, right? As opposed to multiple visits. And eventually somebody's like, have we checked their thyroid levels? I don't think anybody has. Oh my gosh, you're hypothyroid. That's the norm now, where it's many, many visits, and then that happens. Whereas this medicine is very much analytical, especially internal medicine, and it should be able to be done.
It's all algorithm based. It's funny, like right behind me from my medical school days, I'm sure you remember it. It's like, it's really good to work out with, but I have Harrison's internal medicine, and a vast majority of internal medicine in terms of your patient encounters, it's like memorizing these algorithms in your head of like, you ask these questions, and if the patient says this, it's like, oh, it's down this route. If not, it's down this route. And, man, I mean, some people are not going to like this, but like, doctors get tired. They'll miss something. They'll forget something. Maybe they ask the question in a way that the patient doesn't quite understand, and their yes is really a no,
Yeah. And as you know, in medicine, there's another expression. When you hear hoofbeats, it's usually a horse, not a zebra, right? And so some practitioners that have been doing this for a long, long time, they've seen enough horses that they start to forget about the zebras. Whereas an impartial, objective machine would say, okay, let's not forget about the zebras. If it's not definitely a horse, we should cost effectively and efficiently figure out if it's a zebra, right?
Yeah. Just going back to just on the risk side of AI, for the venture investors, and especially what I think is interesting, Dan, is that like now, at least I've spoken to a few of them, but more family offices that are bankrolled and really, really well funded, but coming from like real estate or construction or, some different industry in there, they want to get into MedTech because it's high tech. These are all social good initiatives. I mean, it feels really good to make billions of dollars and know that the company you invested in wasn't some BS, I don't know, social media app or something. But like, what are some risks that those investors have that you kind of caution to kind of pay attention and look out for? I guess like the reason why I'm asking this, Dan, is that like we went through this in 2021, right? 2021 was like the boom of SaaS. So like all of this money just got shoved into SaaS, 2021 to 2022, big boom years. And now SaaS is just getting decimated because they over-indexed on it. So what's your advice, to investors on the risk side of AI and how they should think about it?
Yeah, thanks. And health is different than the other sectors. And if it wasn't different than the other sectors, the four biggest health systems would be Amazon Health, Google Health, Apple Health, and GE Health, right? These would be the four biggest health systems in the world because they have infinite money and they have great with data. So the reality is Google did try to do something here. They tried to do an electronic medical record. I think it must have been 20 years ago now. And they stopped because of the requirements, HIPAA requirements, and the requirements for transparency with the government regulating agencies. So there are significant barriers here to adoption or to implementation of true AI, even artificial narrow intelligence and machine learning algorithms, based on restriction of access to data and concerns over the uncertainty of these algorithms from a regulatory perspective. So the first part is access to data. Most people just assume this is awesome. We're going to implement this thing. We're going to get access to the hospital's data. And then it's going to be able to comb through the EMR records at this hospital and figure out if we missed, even for things that aren't regulated, we're going to figure out if we missed any billing codes that we could have had access to and are not optimizing our hospital's revenues, right? The big problem there is, okay, we're going to get access to the electronic medical record. That is an incredible pain point. Every time you want to get access to an EMR at a hospital, even with an expedited EMR access for data downloads, it's 6 to 9, maybe 12 months per hospital. And it doesn't scale. When you do this at San Francisco General, even though it's affiliated with UCSF, when you go to UCSF, you have to do it again. And it's going to take another 6 to 9, maybe 12 months. And to that point, maybe those radiologists will be the people implementing the EMR extraction algorithms. But so that's a big one. You need to understand how difficult it is to get the ground truth data here. Even for the radiology algorithms, they had to de-identify the images, de-identify the records from the radiologist, and then file an IRB to make sure that they were protecting the patients. So the EMR and access to data is a big one. Another big one is, even if you get those, the FDA, when I worked at the FDA, the first thing they did with us, the way they during orientation, is they told us the story of Frances Oldham Kelsey. And Frances Oldham Kelsey is the woman who stopped thalidomide from entering the market. And you might be too young to remember this, but thalidomide was a morning sickness medicine that was in Europe, and it ended up killing an estimated 80,000 babies, and another 20,000 were born with deformed limbs. The FDA, Frances Oldham Kelsey at the FDA, kept it off the market here and saved 80,000 lives and 20,000 or so deformities estimated. And that's how the FDA operates. It operates, and that's why they had this during orientation, is to show us our job is to protect the population. And so they don't see AI as a way to make medicine better and more efficient. They see it as a way to potentially allow medicine to go haywire and get out of control. So that's why of those 521 AI and ML enabled medical devices, none of them are PMAs, so they're not the highest risk device, and all of them are fixed algorithms.
Can you share with the audience PMA, what PMA stands for?
Pre-market approval. So that's reserved for the higher risk devices, like a pacemaker or a device that could be life-saving or life-threatening in the wrong situation.
What do you think about one example of the kind of more of a B2C play with an enterprise approach to it is like Echo Health. So that's like the digital stethoscope, where physicians are buying, because I think they're $200-300, but then there's this opportunity to like use this AI portion of it. I mean, what are your thoughts on something like that?
Yeah, I think that's very interesting. Especially, it's in line with what I was talking about earlier. If the way they gather the data is proprietary and is not something that is being done with existing electronic stethoscopes, then that's great for them, because now they have this proprietary source of data, and they'll start having their own proprietary database, which they own. There is the tricky question of who owns the data, especially if they don't have a data use research agreement or a BAA in place, a business associate agreement that defines the data as being theirs. But even then, the issue is that they're going to require de-identification of the data and likely an IRB, Institutional Review Board approval, in order to get access to those data. So I think the reality is they are in a decent position, I think, to develop a machine learning algorithm. But going back to the definition of AI and the typical use case where it continues to evolve, and it's not just a fixed machine learning algorithm that has been processed on supervised data and is now fixed and launched. I think the possibility for AI with Echo is great, if they can get access to the the data to supervise their algorithm. But the FDA is going to have a really hard time with the algorithm evolving without them having a say so. So
yeah,
I think have some of the restrictions of existing technologies where in things that I see as well, where to get the data, you have to jump through these hoops, and doesn't scale very well. Not like the rest of the world where ChatGPT, where the scale is the entire internet right now.
Right. Do you feel like the smarter approach here I'm wondering if like for MedTech companies, a smarter approach, the easier approach is this, which is just like how, I guess with robotics, right? The robot was seen as kind of like a Trojan horse to get in, and then you sell disposables. Larger companies acquired those robotic systems because like that's our Trojan horse to get in and sell other stuff. Do you feel like for early stage MedTech companies, the way or maybe the path to ML and AI is to say, okay, we're going to have a device, some hardware, maybe with a consumable to go into the hospital. We have ways to capture data automatically. We're going to just capture and accumulate that, right? And then when you have a certain amount of it, then we can, move forward to bring forward to the FDA and also work with the hospitals through a BAA to figure out what we do with the data. Do you feel like that's the right route versus kind of like trying to do both at the same time, if that makes sense?
Yeah, I definitely do. And as you know, that was our model at Potrero. Potrero, we fixed the problem of urinary retention and other issues with urine building up in the bladder and not being counted as urine output until the nurse came around to break the airlock. So we fixed urine output and made it much easier to get it much more accurately, and eliminated some of the problems of urinary retention. It's looking like we have an impact on urinary tract infections just because we do eliminate the urinary retention, and we eliminate the peeing around the catheter that happens with a full bladder and airlock, all these other things. And we sold it initially as a better temperature sensing Foley catheter that also got intra-abdominal pressure. But once we did that, we now had this device that was sitting on these patients, and we were gathering these data. And I think the sampling is 100 hertz. So we're getting 100 data points per second. A little overkill for urine output and temperature, but it allowed us to look at the waveforms underlying the intra-abdominal pressure, from which we have preliminary data showing we can extract heart rate and even the size and amplitude of the abdominal aortic pulse, which could be related to stroke volume. So the intra-abdominal pressure we wanted at 100 hertz, but we gathered all those at 100 hertz. And by using the urinary output improvements as our Trojan horse, we're now gathering these data on these very sick patients that once we do get the ground truth data on what happened to the patient in the ICU, we can then run these machine learning algorithms to do what we did with acute kidney injury, predict it early.
Nice. Yeah, it's exciting. I'm excited to see like that same model that you kind of developed and perfected with Potrero sort of rolled out across these other portfolio companies at Theranova. Dan, I really appreciate you coming on. I'm going to plug the Theranova's website and everything, but what's the best way for people to get in touch with you? You're on TikTok, right?
No, not TikTok. I don't have that. I've never been a fan of Facebook either. I recognized that it was too much of a time suck early on, so I'm not big on social media. I would say the best way is email. The email is Burnett@theranova.com if you want to reach out.
Fantastic. Well, Dan, we really appreciate you coming on the show, and definitely going to have you back on some of these other topics. So with that being said, this has been another episode of The State of MedTech, and we will see you all next time. Bye for now. Thank you for enjoying another epic episode of The State of MedTech. If you're feeling inspired and love this episode, do us a favor, hit that subscribe button and turn notifications on so you never miss an episode. And be sure to give us 5 stars and write a short review, because that helps more people discover this amazing community of ours. If you're a company who has a executive that you'd like to be on the show, or perhaps you want to sponsor one of the episodes, shoot us an email at hello@khateebandco.com. Take care, and we'll see you next time.